On behalf of Clean Code, I'm me, you are you, and this is population density in Deloitte in R. Problem statement reads as follows. You are working on a data analysis project at Deloitte and you need to analyze a data set containing information about various cities. Your task is to calculate the population density of these cities, rounded to the nearest integer, and identify the cities with the minimum and maximum densities. Pop density should be calculated as population divided by area, and our output should contain city, country, and density. This is a pretty straightforward problem. I don't think there's any hidden nuance or gotcha here. And when we think about the company we're interviewing for in this particular case, Deloitte, we do know that there's an on-site and we do know that there are multiple rounds of technical interview. And so this kind of question does make sense for this kind of company. This is probably in the first three questions of that technical on-site, something just to say, hey, can you showcase your skill and ability and tackle a very straightforward problem? If we look in our data frame, we can see varchar for city and country. That makes sense. Population is an integer. Again, makes sense. And area is a float. Okay, nothing weird there. We go ahead and we run our data frame and we take a look and we do see, hey, area has a zero and area down here has a zero. So we know we're going to have to do some work to work with areas because we know from how they want us to calculate, we will get a divide by zero error if we do not tackle this now. So with that being said, this is our problem statement, but let's also take a step back for a moment and really think if we were on an on-site with Deloitte, what would be important to them? Now, we know Deloitte is a service consulting company, and therefore, there is going to be two key components that anybody working for Deloitte needs to do at this level. One, you have to be technically broad. Any given point in time, the client might ask you to do something, you need really broad skill and ability. So when you're doing your on-site and you have 5 to 6 questions, you should expect a good spread. Don't drill down specifically unless you're told so by a recruiter. But secondly, we know that Deloitte does exclusively client work, meaning any work you do eventually has to be underwritten and signed off on by a client. So if we're thinking like a hiring manager or a senior member of a project team, one of the most important skills and abilities you can showcase in this interview that hopefully gets your name circled and moved on to the next one is, hey, this person can communicate what they're doing technically to a non-technical audience. So while we're going through and solving this, in the back of your mind, be thinking, okay, how am I going to posture and position what I am doing and explaining what and how I'm doing in such a way that I can give my interviewer confidence that I can do this in front of a client and the client is going to feel confident that what they're paying for is a good solution. Okay, that being said, let's jump into the notebook and break down this problem and get a good plan of attack. Okay, now that we're in our notebook, let's kind of start formulating our plan of attack. And let's start by going back through and highlighting things we absolutely have to have. The fact that they're asking for a specific output means they only want this output. They've also given density as a specific calculation, so we wanted to note that. They want us to round to the nearest integer, and they also want a minimum and maximum density. Now, this is what I like to call a trench coat problem. A trench coat problem is a bunch of little steps rolled up all together into one solution. And anytime you're working on a trench coat problem, I think it's normally very fair to use helper functions. I have rarely been asked to do helper functions from scratch, and certainly never in a timed environment like a technical onsite at Deloitte, where you're going to be doing 6 to 7 of these problems with several different people throughout a day. So let's go ahead and denote the helper functions we're going to need. We're definitely going to need a round. I mean, that's name brand right there. There's going to be a min. There's going to be a max. We're going to have to use a select because we're changing things around in our columns. We're going to use mutate, handy little function. And then we're also going to use filter because we have those zeros. Can't forget those zeros. I think that's the little trick in the problem statement there. And then finally, our bind is how we're going to combine everything up together nicely and package it at the end. Quickly, we're just going to go through, make sure we got kind of everything we need. I think that is everything. Now, this is something I love to do in my documentation at work, and I think it really helps clarify the problem-solving process most of the time. In this particular case, they've already told us how we're going to be combining. It's maybe a little overkill to write it out, but I think it's a good habit to get into. Okay. So now that we've extracted from our problem statement what needs to be done, we have our helper functions, and if we didn't have a helper function that could identify us, this is where we could know where we'll be doing the calculation. Definitely important when you're playing for speed in these kinds of interviews. And we know what we have already. We're not missing any information. We don't have to interpolate or make a statistic. Let's go ahead and write out what we want to do, how we're going to do it. So step one, we need to filter the data. Step two, we need to calculate a density. Okay. Step three, we're going to want to find a min. Step four, we're going to want to find a max. And then step five, output everything all together. These are the big broad strokes. Again, this problem is not tricky in terms of its execution. It's tricky because you need to remember the 4, 5, 6, 7 different functions to successfully solve this problem. All right, that being said, I will see you back over in the code editor and we will get coding. All right, welcome back to the code editor. Let's go ahead by importing our libraries. We're going to be using the very handy dplyr here because we're going to be manipulating data. And then the first thing that we said we're going to do is take care of those pesky zeros in our data. So let's go ahead and denote that that's what we're going to do. And let's write that out, how we're going to do it. Now, for the sake of conciseness, I'm not going to walk through how all this code works right now. That'll be at the end of the video. I will go line by line and I will explain what every symbol and jot does. So stick around for that if you need it. If not, this is kind of the blocked out walkthrough. So we're going to be filtering our area, and then we need to recalculate our density. We can't do that off the rip. So we're going to be taking the density calculation is next. The code for that is right there. Next, we need to identify cities with the maximum density. And we will be doing that in a little bit more of a complicated way. That's how that ends up looking. And then if we do a max, we also need to do a min. Don't forget the min. That's something I've only ever seen happen once in professional industry. And it was all funny. We all had a big joke and big laugh about it. But, it definitely wouldn't look too great in this particular interview environment. Now we know we need to merge everything together because we're calling these data frames out and doing those steps separately. Now, we could do it all together in one giant function, but like I said before, we know that Deloitte will place a premium on your ability to technically communicate. And so making this code look better and being able to block it and comment everything will definitely help you when you have to go in front of a client and explain, hey, this is why we build you what we build you. And by the way, this is how it works. Eventually, you got to turn the keys over to the client. And that part really helps if you have nice, clean code written nicely. All right, and then finally, we're going to display our combined density as our solution. Let's go ahead and run our code. R is a little bit slower than other languages, so we're just going to hang out here for a few minutes. Great, everything looks good. Let's go ahead and check our solution. And ta-da, it worked. All right, so on behalf of Clean Code listener, thank you for listening. If you'd like a line-by-line interpretation of the code and what it's doing, please stick around. Otherwise, we'll see you next time. All right, this is After Hours. Let's go ahead and go through line by line and talk about how things are happening here. So in this first block of code, we are taking a new variable called cities population, and we're overwriting it with this altered cities population. So the pipe symbol here is really how I would verbalize it is such that. So cities population is now equivalent to cities population such that the filtered area does not equal 0. So what it's doing is it's saying, hey, everything that's not equal to 0 is getting piped to cities population, and that particular cohort, removing everything but 0, is now being written as cities population. So a little bit of our magic here, and we're overriding a variable of the same name. Altogether though, fairly straightforward. Okay, in this next block, line 8, we're going to be calculating population density. So kind of reading bottom to top, we're going to say, hey, density equals population divided by area. That's going to be mutated or creating a new column to our city's population data frame. And then all of this is going to get bundled together and added to the city's population variable that we already have. So this is going to be accomplished by creating a new column and then doing columnar mathematics. All right, and moving right along, we're going to tackle the maximum density data frame next. So on line 12 here, what this line does is it identifies the rows in city's population data frame where the density column is equal to the maximum value of the density column. Then it's going to select city, country, and density columns from those rows, rounds the density column because that's the only numeric data type that it has to the nearest integer, and restores the new result in the data frame max density DF. So kind of how you want to read I've said it before and I'll say it again here, is you kind of want to read it bottom. That's the way I do it. I don't often work in R, and when I do, I kind of have to remind myself how it all works. But as you can see, hey, we're mutating, creating something new, and we're going to put it up into this part, and then that part gets put up into this part, and that part gets put up into this part, and then that part gets rewritten as a brand new thing. That's how it works in layman. All right, and finally, we have line 24. We're going to go ahead and skip minimum. Minimum is the exact same as maximum. You're just using a different function on line 19 instead of line 13. But let's talk about rbind for a second. The way rbind works, it's functionally like a little bit like a union O, and what it's going to do is stack one data frame right on top of the other. Now, why would we want to do that? Well, because we actually need both data frames separately. We don't have a max density column and a min density column. We just have a density column. So we need to have duplicates in our record. We need to have one record for the maximum, and in that same 3-column setup, we need to have a second record for the minimum. And that's why rdbind works so well. We don't need to do any fancy manipulation. We don't need to overwrite. We just need to stack the two of them together and move about our day. Okay. With that being said, that's the conclusion of this episode of After Hours. I hope it's been helpful. Thank you for watching.